Hello and welcome to this channel, and if you are the first time here, subscribe to the channel by clicking the subscribe button in order to stay updated about the most trending technologies. In this video we are discussing about data science. So, introduction to data science. So the term data science has emerged recently with the evolution of mathematical statistics and data analysis. Data science, also known as data-driven science, makes use of scientific methods, processes and systems to extract knowledge or insights from data in various forms, that is either structured or unstructured. With the help of data science in the next few years, we will be able to predict the future as claimed by researchers from MIT. And they already have reached a milestone in predicting the future with their awesome research in various domains. So, how to solve a problem in data science? So problems in data science are solved using algorithms, but the biggest thing to judge is which algorithm to use and when to use it. Basically, there are 5 kinds of problems that you face in data science. First, is this A or B classification algorithm? Then, is this weird anomaly detection algorithm? How much or how many regression algorithm? How is this organized clustering algorithm? And what should I do next? Reinforcement learning algorithm. So, how these algorithms work? So these algorithms are based on human psychology. So we like being appreciated. Right, so computers implement these algorithms and expect to be appreciated when being trained. How? Let us see. So rather than teaching the computer what to do, you let it decide what to do, and at the end of that action, you give either positive or negative feedback. Then, data science life cycle. So a common mistake made in data science projects is rushing into data collection and analysis without understanding the requirements or even framing the business problem properly. Therefore, it is very important for you to follow all the phases throughout the life cycle of data science to ensure the smooth functioning of the project. First, discovery, then data preparation, model planning, model building, operationalize, and then communicate the results. So, discovery. So, before you begin the project, it is important to understand the various specifications, requirements, priorities, and required budget. And you must possess the ability to ask the right questions, and here you assess if you have the required resources present in terms of people, technology, time and data to support the project. And in this phase you also need to frame the business problem and formulate initial hypothesis to test. Then, data preparation. In this phase, you require an analytical sandbox in which you can perform analytics for the entire duration of the project, and you need to explore pre-process and condition data prior to modeling. Further, you will perform ETLT, extract, transform, load and transform, to get the data into the sandbox. So let us have a look at the statistical analysis flow. First, preparing the analytics sandbox, performing ETLT, data conditioning, then survey and visualize. Then model planning. Here you will determine the methods and techniques to draw the relationships between variables, and these relationships will set the base for the algorithms which you will implement in the next phase. And you will apply exploratory data analytics (EDA) using various statistical formulas and visualization tools. So let us have a look at various model planning tools: R programming, SQL analysis services, and SAS or Access. Then model building. In this phase, you will develop data sets for training and testing purposes. Here you need to consider whether your existing tools will suffice for running the models, or it will need a more robust environment like fast and parallel processing. And you will analyze various learning techniques like classification, association, and clustering to build the model. And you can achieve model building through the tools like SAS Enterprise Miner, WEKA, SPCS Modeler, MATLAB, Alpine Miner, and Statistica. Then operationalize. In this phase, you will deliver final reports, briefings, code, and technical documents. And moreover, sometimes a pilot project is also implemented in a real-time production environment. And this will provide you a clear picture of the performance and other related constraints on a small scale before full deployment. Then communicate results. Now, it is important to evaluate if you have been able to achieve the goal that you had planned in the first phase. So in the last phase, you identify all the key findings, communicate to the stakeholders, and determine if the results of the projects are a success or a failure based on the criteria developed in phase 1. Then introduction to machine learning. So the term machine learning was first coined by Arthur Samuel in the year 1959. And looking back, that year was probably the most significant in terms of technological advancements. If you browse through the internet what is machine learning, you will get at least 100 different definitions. However, the very first formal definition was: a computer program is said to learn from experience C with respect to some class of task T and performance measure P, if its performance at a task in T as measured by P improves with experience C. Tom Mitchell. So, what is machine learning? So, in simple terms, machine learning is a subset of artificial intelligence or AI, which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do so. And in this sense, it is the practice of getting machines to solve problems by gaining the ability to think. So how machine learning works? So it enables the computers or the machines to make data-driven decisions rather than being explicitly programmed for carrying out a certain task. And these programs or algorithms are designed in such a way that they learn and improve over time when exposed to new data. But wait, can a machine think or make decisions? Well, if you feed the machine a good amount of data, it will learn how to interpret, process, and analyze this data by using machine learning algorithms. And a machine can learn to solve a problem by following any of the three approaches. So the types of machine learning: first supervised learning, then unsupervised learning, and then reinforcement learning. So supervised learning. Supervised learning is a technique in which we teach or train the machine using data that is well labeled. And to understand the supervised learning, let us consider an analogy. So as kids, we all needed guidance to solve math problems, and our teachers helped us understand what addition is and how it is done. So similarly, you can think of supervised learning as a type of machine learning that involves a guide. And the labeled dataset is the teacher that will train you to understand patterns in the data. And here the labeled dataset is the training dataset. So types of supervised learning are regression and classification. In regression we have linear regression and logistic regression. And in classification we have support vector machine, decision tree, etc. Then unsupervised learning. So unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without guidance. So the model learns through observation and finds structures in the data. And once the model is given a data set, it automatically detects patterns and relationships in the data set by creating clusters in it. So what it can do is add labels to the cluster. Like it cannot say this is a group of apples or mangoes, but it will separate all the apples from mangoes. Suppose we presented images of apples, bananas and mangoes to the model. So what it does, based on some patterns and relationships, it creates clusters and divides the data set into those clusters. And now if a new data is fed to the model, it adds it to one of the created clusters. Then types of unsupervised learning. We have clustering and association. And in clustering we have hierarchical clustering, k-means clustering and KNN clustering. And in association we have a priori algorithm and FP growth algorithm. Then reinforcement learning. So reinforcement learning is a part of machine learning where an agent is put in an environment and it learns to behave in this environment by performing certain actions and observing the rewards which it gets from those actions. And in other terms, it is the ability of an agent to interact with the environment and find out what is the best outcome. So it follows the concept of the hit and trial method. The agent is rewarded or penalized with a point for a correct or a wrong answer, and on the basis of the positive reward points gained, the model trains itself. And again, once trained, it gets ready to predict the new data presented to it. So this type of machine learning is comparatively different. So types of reinforcement learning are positive and negative. Then languages to work with the data science. So a programming language is an arrangement of a set of instructions written in a way to generate various kinds of output. And these are used in computer programs that help in implementing various algorithms and have a wide range of applications. So talking about data science, we have several programming languages that provide a comprehensive set of libraries for performing various data science functions. And a data scientist must have command over at least one language in order to optimize the process. So some of the major languages used for data science are Python, JavaScript, R programming, SQL, Scala and Julia. And among all these, R is considered to be the best programming language for any statistician, as it possesses an extensive catalogue of statistical and graphical methods. Python, on the other hand, can do pretty much the same work as R, but it is preferred by data scientists or data analysts because of its simplicity and high performance. R is a powerful scripting language and highly flexible, with a vibrant community and a resource bank, whereas Python is a widely used object-oriented language that is easy to learn and debug. So Python for data science. So Python is no doubt the best suited language for a data scientist. So the few points that will help you understand why people go with Python for data science. First, driven by vast and active community. So Python has one of the most known and active community which helps them in the continuous improvement of Python as a programming language. And it is distributed under an open source license which makes its development easy via open source contributions. Then learning curve. So with most of the programming languages, their learning curves tend to grow parabolic with time, which means it is hard to grasp early, but as you become familiar with this language, the learning becomes easy. Whereas in the case of Python, the learning is easy because of easy syntax and short handwriting. Then third-party libraries. Standard Python package installer PIP can help you install numerous modules that make Python interactive. And these libraries and modules can interact with internet protocols, operating system calls and many more. Then integration with other languages. So integration libraries like Cython and Jython make Python integrate with C or C++ and Java for cross-platform development. And this makes Python even more powerful, since we all know every language has its own purpose. So using these libraries, you can enjoy the powerful features of each language. Then R programming for data science. So R is basically an open source programming and statistical language. It is a multi-purpose programming language popularly used in the field of data science. Data manipulation. So with R, you can easily shape the data set into a format that could be easily accessed and analyzed by slicing large multivariate data sets. And R has built-in functions for data analysis. So in R, we can use the summary built-in function to analyze summary statistics. Whereas in Python, you need to import packages such as stats models to do this. Then 8,000 plus packages. So R has over 8,000 packages that can be used to implement various statistical analysis tools related to hypothesis testing, model fitting, clustering techniques and machine learning. Then data visualization. So provides a comprehensive set of functionalities for data visualization that helps in understanding a data set and the relationship between various variables. Then massive community support. So R is the most sought after technology because of its ingenuity and community support. Over 2.5 million users are using R, and companies such as TechCrunch, Google, Facebook, Mozilla, etc. make use of R. Then data science tools. So the main feature of data science tools is that you don't have to use programming languages in order to implement data science functions. and they come with predefined functions, algorithms, and a very user-friendly GUI. So hence they can be used to build convoluted machine learning models without the use of a programming language. So several startups and tech giants have been working on developing such user-friendly data science tools. However, since data science is a very vast process, it is often never enough to use one tool for the entire workflow. So let us take a look at data science tools used for the different stages in a data science process. So we have data storage, exploratory data analysis, then data modeling, and then data visualization. So data science tools for data storage. First, Apache Hadoop. So Apache Hadoop is a free open source framework that can manage and store tons and tons of data, and it provides distributed computing of massive data sets over a cluster of thousands of computers, and it is used for high-level computations and data processing. Then Azure HD Insight. So Azure HD Insight is a cloud platform provided by Microsoft for the purpose of data storage, processing, and analytics. And enterprises such as Adobe, Jet, and Millman use Azure HD Insights to process and manage massive amounts of data. Then data science tools for exploratory data analysis. Informatica Power Center. So the buzz around Informatica is explained by the fact their revenue has rounded off to around 1.05 billion. So Informatica has many products focused on data integration. However, Informatica Power Center stands out due to its data integration capabilities. Then RapidMiner. So there is no surprise that RapidMiner is one of the most popular tools for implementing data science. RapidMiner is ranked at number 1 in the Gartner Magic Quadrant for Data Science Platforms 2017 and in the Forrester Wave for predictive analysis and machine learning. Then data science tools for data modeling. H2O.ai. So H2O.ai is the company behind open source machine learning products like H2O, aimed to make machine learning easier for all. And with around 130k data scientists and approximately 14k organizations, the H2O.ai community is growing at a strong pace. And H2O.ai is an open source data science tool that is aimed at making data modeling easier. Then Data Robot. So Data Robot is an AI-driven automation platform that aids in developing accurate predictive models. And Data Robot makes it easy to implement a wide range of machine learning algorithms, including clustering, classification, and regression models. Then data science tools for data visualization. Tableau. So Tableau is the most popular data visualization tool used in the market, and it allows you to break down raw unformatted data into a processable and understandable format. Visualizations created by Tableau can easily help you understand the dependencies between the predictor variables. QlikView. So QlikView is another data visualization tool that is used by more than 24,000 organizations worldwide, and it is one of the most effective visualization platforms for visually analyzing data to derive useful business insights. Then data science frameworks. So now we introduce you the best frameworks present in data science world and help in solving various data science day-to-day problems. So the best frameworks are TensorFlow, PyTorch, Scikit-learn, Spark and MLlib. So TensorFlow. TensorFlow is a library based on Python that provides different types of functionality for implementing deep learning models. So the term TensorFlow is made up of two terms, tensor and flow. And in TensorFlow, the term tensor refers to the representation of data as a multi-dimensional array, whereas the term flow refers to the series of operations that one performs on tensors, as shown in the image. So basically, the overall process of writing a TensorFlow program involves two steps: building a computational graph and then running a computational graph. Then scikit-learn. So scikit-learn is a library used to perform machine learning in Python. Scikit-learn is an open source library that is licensed under BSD and is reusable in various contexts, encouraging academic and commercial use. And it provides a range of supervised and unsupervised learning algorithms in Python. And it consists of popular algorithms and libraries. And apart from that, it also contains the packages like first NumPy. So NumPy is a Python package that stands for Numerical Python, and it is the core library for scientific computing, which contains a powerful n-dimensional array object. Then matplotlib. So matplotlib.pyplot is a plotting library used for 2D graphics in Python programming language, and it can be used in Python scripts, shell and web application servers. Then SciPy. So SciPy is an open source Python library used to solve scientific and mathematical problems, and it is built on the NumPy extension and helps in data manipulation and visualization. Then PyTorch. So PyTorch is a Python based scientific computing package targeted at two sets of audiences. First, a replacement for NumPy to make use of the power of GPUs. Then deep learning research platform that provides maximum flexibility and speed. Then features. Native support. So native support for Python and use of its libraries. Then used in Facebook, actively used in the development of Facebook for all of its deep learning requirements in the platform. Then easy to use API. So PyTorch ensures an easy to use API which helps with easier usability and better understanding when making use of the API. Fast processing. So PyTorch is fast and feels native, and hence ensuring easy coding and fast processing. Support for CUDA. So the support for CUDA ensures that the code can run on the GPU, thereby decreasing the time needed to run the code and increasing the overall performance of the system. Then dynamic computation graphs. So dynamic computation graphs are a major highlight here, as they ensure the graph build up dynamically, and at every point of code execution the graph is built along and can be manipulated at a runtime. Now Spark MLlib. So Spark MLlib is Apache Spark's machine learning component. So one of the major attractions of Spark is the ability to scale computation massively, and that is exactly what you need for machine learning algorithms. But the limitation is that machine learning algorithms cannot be effectively parallelized, and each algorithm has its own challenges for parallelization, whether it is task parallelism or data parallelism. So Spark.mllib contains the original API built on top of RDTs, and it also provides higher level API built on top of data frames for constructing ML pipelines. So Spark.ml is the primary machine learning API for Spark at the moment. Then Spark ML Lib tools. So ML algorithms form the core of ML Lib. Pipelines provide tools for constructing, evaluating and tuning ML pipelines. Utilities for linear algebra, statistics and data handling. Featureization. It includes feature extraction, transformation, dimensionality reduction and selection. Persistence. Persistence helps in saving and loading algorithms, models and pipelines. So ML Lib algorithms are basic statistics, regression, classification, clustering, recommendation system, dimensionality reduction, feature extraction and optimization. So some of the important frequently asked interview questions. First, what is data science and how would you say it is similar or different to business analytics and business intelligence? Then which package is used to data import in R and Python and how do you data import in SAS? Then how do you build a custom function in Python or R? What is an RDBMS? And name some examples of RDBMS and what is CRUD. Then define a SQL query and what is the difference between select and update query and how do you use SQL in SAS, Python and R language. Then what is an API, what are APIs used for, what is NoSQL and name some examples of NoSQL databases, what is a key value store, what is column storage, what is a document database. Then what is a data warehouse, what is JSON and what is XML and name some kind of graphs and explain how you would build them in Python or R. Then how do you check for data quality. Then what is an outliner, how do you treat outlier data. Then what is missing value imputation, how do you handle missing values in Python or R. Then why do you need a for loop, what do you do for loops in Python and R. What is the advantage of using the apply family of functions in R. Then how do you use lambda in Python. What packages are used for data mining in Python and R. Then what is machine learning, what is the difference between supervised and unsupervised methods, what are random forests and how is it different from decision trees. Then what is logistic and linear regression and name some packages in R and Python for building regression models. What is linear optimization, where is it used and what is the traveling salesman problem. What is card and child and how is bagging different from boosting. What is a Z test, chi-square test, F test and T test. Then what are entropy and information gain in the decision tree algorithm. So these are some of the data science interview questions which can be asked in an interview. Then so who is a data science professional? So a data science professional dons many hats in his or her workplace, and they are not only responsible for business analytics but also are involved in building data products and software platforms, developing visualizations and machine learning algorithms. Now data scientists. So data scientists are those who crack complex data problems with their strong expertise in certain scientific disciplines. and they work with several elements related to mathematics, statistics, computer science, etc. And they make a lot of use of the latest technologies in finding solutions and reaching conclusions that are crucial for an organization's growth and development. Then data architect. So people with the traditional programming and business intelligence background, also good at dealing data ambiguity, have all the prerequisites to become data architects. And they are often familiar with undefined and unstructured type of data and statistics. And data architects are also creative enough to harness the data in a few ways for new insights. Then database administrators. So database administrators are responsible for administrating the collected data is an important task for organizations' decisions, and they make use of multiple software tools to store and organize data for further analysis. Then data visualizers. So data visualizers are technologies who translate data analytics into vital information for business to use, and they manage to harness the data analytics in layman's language to be able to communicate the outcome to all parts of the company. Then data engineers. So data engineers are the heart and the soul of data science, and they are responsible for designing, building and managing the big data infrastructure, and they do play a major role in developing the architecture to analyze and process the data according to the business need. Then data analyst. So data analysts deliver value to their company by taking information about specific topics and then interprets, analyzes and presents findings in comprehensive reports. And many different types of businesses use data analysts to help. And as experts, data analysts are often called on to use their skills and tools to provide competitive analysis and identify trends within industries. So this was a brief discussion on data science, and we will be discussing more on data science in the upcoming videos. And if you are the first time here, subscribe to the channel by clicking on the subscribe button in order to stay updated about the most trending technologies. Thank you for watching this video. Bye for now.